Our next speaker is a professor at the School of Interactive Arts and Technology, Wolfgang Stuerzlinger, and he's an expert in virtual reality and human-computer interaction. And so with that, I'll let Wolfgang address you about his research.
So I'll start with a simple sentence here. We use unreliable systems as a central means to interpret input actions. And you go like, what? Autocorrect is a simple explanation. So if you can't read it, I still owe you monkeys. Don't let me forget. Monies. Damn it. Damn that autocorrect. Please play me in monkeys. I would rather have monkeys. And this one is actually from my own log. Not swords. Not what I said. I said, not a worry. My response was only, lol, gotta love autocorrect. So we use this more and more in our daily lives. If you don't believe me, if you have one of those speech recognition devices, Google, Amazon, Alexa, and various other things. We have devices like augmented reality devices like the HoloLens, where you try to hit the menu in mid-air, and it sometimes works, most of the time. We have things like lane departure warnings in our cars that work sometimes, most of the time, not always. Blind spot warnings, sometimes you drive down a road and suddenly there's a car right beside you and you go like, there's no lane beside me. Well, that was this post mailbox thingy that triggered the warning, and you go like, what the hell? And various other things. Now, the dark side of this is, of course, that we sometimes rely too much on this. Happy birthday to you, happy birthday to you, happy birthday, dead husband, happy birthday to you. Thanks, I assume you meant dear. Yes, I mean, that is a crazy autocorrect, sorry, babe. And of course, Tesla, and various other issues with autopilots, which are in essence also unreliable systems, just makes the point. So now you can ask, how do we address this? And the standard technological answer, and the School of Interactive Arts and Technology, and now emphasizing the technology part, is we need the Department of Better Technology. And of course we can use that. But if you look at that and you think about it for longer, you discover that the language, gestures, and all of these things are more ambiguous and more varied than you think. The world is complex, so we have to have a human in the loop. I know that our robotic overlords disagree with this, but it is still required. So I'm pursuing in this project a complementary approach where I'm looking at trying to understand humans better and how humans deal with systems that don't always work. That includes the perceptual, cognitive, and physical aspects of this, and then build on this and build new user interface technologies. Now, of course, I don't have all answers, so this is a bit of a journey, and I'll talk about some of the things that I've reached in that journey. Now, I will notice that fixing errors seems to be a simple issue, right? But if I break it down a little bit, you have to notice an error. You have to decide if it's worth fixing. Depends on the context, right? If I write an email to my dean about $5 million, that's different than if I write an email to my buddy about going for a beer. And the concept of ecological rationality is clearly relevant here. Then you have to figure out how to correct the error, and then you have to correct it. So that quite a few steps to fix a simple error of an autocorrect or something like that, or if you just tried to order 2 tons of carrots from Alexa or something like that, involuntarily. The issue is errors can happen at every step here. And worse yet, errors on errors can happen, right? If you ever made an error correction and then you made errors where during the error correction you feel the pain, right? If you really feel the pain at that point. So I just want to put that there just to explain the depth of the issue, because it's not as simple as, oh, we just need to reduce the errors. No, you also need to worry about the errors and all of the process steps that happen in between. So here are some research projects that we've done in the past where we have looked at what happens in 2 domains here. One of them is a very simple form of torture. I give you a keyboard, it's a normal mechanical keyboard, and I just, in software, make the keyboard not work quite correctly, right? And I do it sneakily, so I give you adjacent keys instead, so you know it's not quite random. That worked quite well. We tried, you know, a range of different errors. It turns out then 10% errors is enough to get people to swear. The unpublishable metric of unprintable words per hour applies totally, okay? 5% errors is noticeable. People go like, something's off here, but I can't quite tell. And 1% and 2% errors is within the human error rate. So that convinced me in various ways that there is a threshold here. In a sense that if the system works almost perfectly, it's actually good enough. So 1% or 2% error rate is fine, but 10 or 20% is not. Now, you say, well, okay, that's great news. I will point out that a lot of machine learning-based systems are 70% accurate, which is a 30% error rate. Okay, I'll just point that out. So there's lots of work to be done here for that reason. Now, in text entry, we have tried to ameliorate the situation. Wise Type was a paper that Ohud Al-Harbi published in 2019, and she presented various mechanisms, including a grammar checker on a mobile phone, or a mobile platform more precisely, and showing which words were autocorrected and came from the prediction panel, and that actually helped to make text entry more accurate and faster, both in this case and with a context-sensitive menu. Interestingly enough, some of these mechanisms have been picked up, for example, in Google Android in the meantime. Now, when I talk about autocorrect, a lot of people go like, well, okay, yeah, autocorrect is cool and so on, and it sometimes fails, but people will adapt to it. And that is something that I want to challenge. Because errors can happen repeatedly, yes, and in theory, humans can adapt. But adaptation happens only if things are predictable. So now you get a new phone, or your phone gets a software upgrade, and the autocorrect algorithm got upgraded. How can you predict the algorithm? You can't. There's a simple answer. Basically, the whole algorithm has been changed, right? And that actually causes a lot of problems. Moreover, all of these systems, the autocorrects are typically adaptive, and so your own history actually changes the autocorrect, and your own input changes the autocorrect continuously, making it harder and harder to predict. You can't learn from them. So generally, users are unable to predict underlying systems. I've also studied this in a more explicit way, where we made a gesture recognizer where you basically draw gestures on a tablet, and we ask people to switch to a different gesture if the gesture recognizer did not work well. And that kind of worked. Similar result that 90% accuracy is pretty much required. The thing that gave me a lot to think about is that people did this study they entered gestures for well over half an hour. Only 7 gestures, with each one of them an alternate. Right? So a very small set. Half of the participants, after having played with the system, the whole study lasted almost an hour with the training and everything, were unable to tell which of the letters were faulty. Half of the participants. That gave me a lot to think, because it basically means, well, you can adapt if you notice it, and they have to happen frequently enough, and they need to be predictable, and they need to be worth it for the person. So driving on the left side of the picture is not flipped, okay? Driving on the left side of the road is something you can adapt to. And as somebody has done vacation in New Zealand or other countries where you drive on the left side of the road, or UK, you can do it, but it's hard, right? Now, going out on a crazy limb here, we tried to really fix the problem. We built a system that makes autocorrect magical. And the way we did this is put an EEG headset on people's heads. Yes, not exactly user-friendly, I agree. Especially since there's gel involved, so you have to take a shower afterwards, so nobody likes those, but we do science. It's all in the name of science. The point is, you can sense some of the negative reactions when you see that the system has done a wrong autocorrect. you can send that signal in the EEG signal. So it's quite tricky, involves a lot of machine learning. It took us only 3 years. We needed also to use eye tracking and textual context like word length and various other measures. And if we can detect it and everything works together, then the system does the following. Instead of having the wrong autocorrect, it can switch it to another one, which may be then correct. And we got the system to work. We got it published at CHI, which is best conference in human-computer interaction, so that's great. But the reality of it is we got that to work with about 70% reliability. So our work is still done. There's more work to be done, let's put it this way. So can we eliminate all failures? No, lots of issues around that. There's also, if you push too much on that, clearly you will make things too straight railroaded, and then you can run into some small legal issues. No, you can't drive on the highway. There's automation bias, and one thing that I'm also always running again, people misperceive probabilities, right? You overperceive unlikely events and underperceive likely events. There's a classic cases in there. So we're still working on it. What do we want? An end to autocorrect errors. When do we want it? Cow. So I can only stop by thanking all the students who helped me with this research, and I'm open for questions.